Alrighty, I think I'm going to get started. First of all, thank you very much for coming out, everybody. It's great to have you all here. I'm going to be talking about our path to creating the Lyft Driver app and how we used recycling to do so. But first, I'm going to talk about myself. I went to Michigan State University after graduating. Go green! Oh, okay. After graduating, I went to Microsoft and worked at Windows and Office for about a year each. And then I've been at Lyft for about a year now. I like drinking beer, and the best way to work it off is to bike around for me. So I like biking around Seattle. I'm actually from Seattle. And I've been drawing and painting for a while now. And just to, I guess, reiterate what's up there, I'm an Android engineer on the driver experience team at Lyft. All right, so what am I going to be talking about today? Before I get into that, I kind of want to take a poll. Who here has ridden in a rideshare car before? Cool. Who has ridden in a Lyft before? Even better. Who has driven for Lyft? Am I the only? Okay. All right. There's two of us. Awesome. So the first thing I'm going to talk about is the driver experience. What is the driver experience on the Lyft platform? A lot of people have been in a car with a Lyft driver, but they haven't actually seen what the life of a Lyft driver looks like. So I kind of wanted to iterate that since we're going to be going over what the driver app, what we did to create the driver app. Secondly, I wanted to go over the motivations for why we decided to break the driver app functionality out of the unified app, as we call it, and into its own separate app. And there's two main considerations that we took into consideration for this. The first being the product side of things, so what we actually shipped to our users. And secondly, what happened in the background, so all the engineering efforts that were improved by this. And finally, how? How did we go about creating this? All right, so first, I'm going to talk about the driver experience and what a driver experience is on a day-to-day basis. Okay, so if you've downloaded the Lyft app before, on the side menu, you might have seen this switch to use driver button or become a driver. Tapping on that will actually take you into the default driver experience, which is what we call offline mode. In offline mode, a driver can see a few different things. They can access their earnings, they can refer other drivers, and they can see a heat map of where people are requesting rides. That's what all of these pink squares are. And they can also see updates that we send to them. Once a driver decides, hey, like it looks like there's enough demand, I'm going to start giving rides. They can tap that Go Online button at the top, and that will take them into what we call the online mode, where they're dispatchable by Lyft. And so when a passenger requests a ride to go somewhere, they can start getting ride requests, which is what happens next. So when a passenger requests a ride, a driver gets a ride request. So they don't automatically get dispatched to a ride. The driver has to accept this ride. And they can see some information about the passenger, like how far away they are, how much extra bonus they may get on top of the ride, so prime time, and the passenger's rating. Yes, everybody here who has Lyft has a passenger rating. All right, so when they accept the ride by tapping in this area, they then get booted into a navigation app. And actually, this is slightly older, and there's actually 3 options now for drivers to navigate to their passenger and to the passenger's destination. They can use Google Maps, they can use Waze, and then we recently integrated a Google Maps navigation SDK into the Lyft Driver app so they can actually stay inside of the Lyft app to navigate as well to pick up their passenger. All right, so they get to their passenger, and then they pick them up. And this might be a screen that you've seen before while riding in a Lyft. And if not, you've definitely seen the next step, which is navigating again to where you want to go, again, using any one of those 3 navigation options. Once when the driver gets to your destination, they then drop you off and rate you. As I said before, yes, everybody gets rated. And if a ride is below 3 stars by either the passenger or the driver, the pairing never happens again, just to make sure that if any bad experiences happened, we don't repeat those in the future. All right, so I kind of went through what we call the golden path there, but there's just a ton of driver functionality that we've built into the app. And if you have any questions about kind of what a driver can experience and what some of that functionality is, please come up and talk to me either after this or up at the booth upstairs. I'd love to talk more about it. Okay, so why did we decide to create this driver app? That's a great question. So as I said before, there were 2 kind of main considerations. The product, so what we actually ship to our users, and then the engineering side of things. And there are some considerations within those that I kind of wanted to dive into. So firstly, the product motivations. A few years ago, when Lyft was first getting started, we shipped 1 app. And we thought that this was a good idea because we thought that passengers would become drivers and drivers would become passengers. So this app had 2 modes that you could switch between, a driver mode and a passenger mode. And at first, this actually held true. People were switching pretty frequently between the two. But as our user base grew and as the company matured, we found that more and more drivers were just drivers, and more passengers were just passengers. Now, this isn't 100% true across the board, but it's definitely more the case now than it was 5 years ago. And so why ship all of the passenger functionality to our drivers, and why ship all of the driver functionality to our passengers, if on the whole, each group is using just one set of that functionality? Alrighty. And so now, what about engineering motivations? There were two kind of main considerations that we had here. One was reducing what I like to call app bloat, and I'll get into that in a second, and then also increasing the rate that our engineers could produce features within the both the passenger app and the driver app. All right, so first, app bloat. What am I talking about with app bloat? Well, first of all, less app size. This is really important for when users are trying to update their apps. If the app is really, really huge to update, less users are going to want to update because of cellular data. And on iOS, there's actually that limit that you can hit where you can no longer even get updates on cellular data, and you have to update on Wi-Fi. But we release a lot of updates, and we want to make sure that our users have the most up-to-date functionality that we can provide. This also allows us to integrate new SDKs and features that may take up a lot of size without hitting that, because we were able to reduce the app size. And the navigation SDK that I talked about before is an example of that. We were able to do that within the driver app without having to ship all of this SDK functionality in the passenger app. And then also the holy grail of mobile apps is start time, making sure that the app starts really quickly. And so basically reducing all of our dagger graph initialization. As you know with this, every single millisecond counts. So really shaving off as much as we can off of each app's start time. All right, so also we wanted to increase feature development. Although not every single feature relates with driver and passenger functionality, when we did have some features that shipped that actually the driver stuff would break passenger functionality or vice versa. And separating all of that functionality out into two apps allowed us to silo those two so that we didn't accidentally break a part of the passenger app by shipping a driver feature or vice versa. Another side of this is the fact that we wanted to have different ship cycles. We didn't want to have to ship a hot fix for a passenger bug to all of our drivers and vice versa. Also, when creating large features, you're inevitably going to be shipping more bugs inside of the app. And so we were able to confidently ship larger features for passengers and confidently ship larger features for drivers without having to worry about destabilizing the other mode of the app. My favorite benefit of this is module ownership and increasing the number of modules that we had within the app. As the Lyft code base has grown on the Android side of things, we can no longer have just one group of people that understands everything that's going on within the app. So the code base is just getting too large. And so as part of this, domain experts kind of arise that understand the functionality of their code really, really well. And having modulars with feature ownership means that we can give these owners the power to oversee changes in their code and to veto changes that may break things that were unforeseen for a newer member of the team or somebody who's new to the code base. And hopefully this leads to less bugs. I kind of wanted to just take a screen capture here of some of the modules that we had. I think we have definitely over 100 now within the Lyft app. And each one of these modules corresponds to a specific feature that does a specific thing within the app. And within each of these modules, we have an owners file. And each of these owners files contains a list of GitHub handles that relates to the owners of that file. So when you're going to have a PR, we can do a check to say, hey, did the right people sign off on the changes that you made in this module? And that's a great way to kind of, again, check to make sure that, hey, we're not breaking something inadvertently by breaking something that was a decision that was made a long time ago. And so as you can see here, we can't push this to master in GitHub because the owner's check has failed. And as part of that, we can actually surface these GitHub handles to our the person who's posting this PR, and it kind of helps from pushing a breaking change so that the little RC car doesn't hit the app in a bad way. All right, so we've kind of gone through the why. So how did we go about doing this? Whenever I talk about kind of splitting this app and creating these two different apps, I think of a ball of dough. A ball of dough that has some passenger functionality, maybe some driver functionality, and then some shared components that both of those functionalities use. If you've ever used or needed dough before and tried to pull it apart, you know that if you're not really careful about pulling it apart, a giant mess can happen. And I think that that sort of thing could have happened here. And so we really need to be very careful and precise in how we decided to split apart this functionality. All right, so I'm going to start off with the golden vision of what we wanted to end up with our two apps. We wanted to have a driver app module that took in driver feature modules as well as some shared modules and created a driver app. And we wanted to have a passenger app module that took in some passenger features and shared components as well and created the passenger app. So completely separate, a separate module tree here that then produced two distinct apps. But that's not what we had. What did we actually have? We had this monolithic Lyft app module, which owned a bunch of different things, some of which made sense, like the initialization of the app, some of which didn't make as much sense, which I'll go into a little bit later, kind of like deep links or long-running jobs that are running out throughout the entire lifecycle of the app. And that produced our one app with its two different modes. All right, so the first thing that we had to do while we were creating this app was just create a driver app target that just had all of the passenger mode turned off automatically. So that the users of the driver app would just only be able to see the driver functionality, but we'd still be shipping all of the code with the passenger app. This allowed us to transition drivers over while we were working on the app split itself. So we could actually test out any breaking changes that we might have introduced while we were refactoring our code to be more modularized. This is pretty cool. However, as the drivers were using this, it still didn't give us any of the benefits that we wanted. So it looked like we were done, but we really hadn't even started. Okay, so I'm going to go back into our module structure here just to give a clearer idea of what's going on. So we had this Lyft app module that controlled a bunch of different things that had to do with the app. And then we had some feature modules, passenger features, driver features, and then some modules that contained kind of both of them. And I'll get into what that means later here. So that looks a little iffy. And then also we had a bunch of shared modules like frameworks, mapping, APIs, widgets, the list goes on, that all of these modules then took dependencies on, and then the Lyft app module produced into the passenger app. So like as I was saying, there are some things that are a little sketchy here. So we see some stuff in this Lyft app module that doesn't look quite right. If we're going to be splitting this functionality apart, should it really be sitting in this app module? Also, we see these mixed features. This doesn't seem like something we'd have if we had distinct functionality for both passenger and driver apps. And finally, although it doesn't look like it on here, there's definitely some iffy things going on in these shared components as well. So there were definitely some issues that we had to address before we could start actually splitting off all of this functionality. And as we were doing this, I noticed three major strategies. There's no silver bullet when modularizing code, but I noticed three things that we definitely used over and over again, and I kind of wanted to highlight those as how we went through splitting the app. So the first being that we reduced modules to just do a specific thing. We didn't want to have too much extra functionality in a module that didn't make sense for that module, so we wanted to reduce that down. Secondly, we wanted to reuse modules that make sense in a way that makes sense. So those common modules, only ensuring that we have only common code and common components in those modules. And finally, recycling. When I think of recycling, I think of melting something down and distributing it out in a more distributed manner. And so we wanted to make some of this main monolithic module and turn it into something a little smaller and distributing some of the functionality that it had across more shareable modules. All right, so first I'm going to talk about reducing. So how did we go about making sure that modules did only what they really should be doing and having more fine-grained responsibilities? The example that I like to use here is our settings page, because settings is very, very similar between driver and passenger functionality, but it's not quite exactly the same. So as you can see here, there's looks like there's a profile that you can select, maybe an email, a phone number, but then things start kind of differing between the driver and the passenger. The driver can choose their navigation options, so what they use to navigate to get to their passenger and get to the drop-off, which a passenger doesn't need, because if they were navigating, then they probably wouldn't be using Lyft, right? And on the passenger side of things, they have a business profile. So when they're out traveling, they can charge their business their Lyft rides instead of paying for them personally, which a driver doesn't really need to do because they're the ones giving the rides in the first place. So there's definitely some functionality here that's overlapping and some functionality that's not. So if we look at this in box form, we see that yes, there's some edit email functionality, edit phone number, navigation settings, business profile, and all of these were in one Lyft settings module. So we had both driver and passenger functionality being pulled into the settings module that was being shipped for both drivers and passengers. That's great if we have one app, but we didn't want one app. So what did we do? Instead, we broke out all of the common components, so maybe editing email, editing phone number, and a few other things. And then we broke out the driver-specific settings and the passenger-specific settings. So then the only part that was shipped with both apps was the common settings module that really needed to be shipped in both anyways. And so we're not pulling in all of these dependencies from other passenger features or driver features and shipping them to drivers and passengers. And we did this in a few different places. Some of the components in our APIs, our widgets, the help screen was almost identical to this. So we had a help screen that some functionality was the same for passengers and drivers, but then it also differed quite greatly later on. All right, so secondly, we wanted to reuse modules that made sense. So these common modules, again, we wanted to make sure that they were actually common and they didn't have specific driver or passenger functionality. This is an example of a place where that was not the case. We had a core module that had some ride request classes in it. Interestingly enough, we also had a ride request module. So it doesn't really make sense to ship these ride request classes in driver features because a driver is accepting rides and not requesting them. And so even if a driver feature needs some of the other core module components, they're still getting these ride request classes that they don't really need. And so what makes sense to do here is to just move these ride request classes into the ride request module instead of having it in this core module. Now, let's say another passenger feature needs these ride request features. We can have modules obviously take dependencies on themselves to allow these ride request classes to still be used where it makes sense. And so we ended up having to do this a few different times in some common UI components, some of our frameworks and other business logic. It's interesting how many different times that we actually had to do this in slight permutations. Like I said, there's really no exact silver bullet here. It's more of a case by case, trying to figure out how to move things around in a way that makes sense. All right, so finally, recycling. We had this monolithic app module, and we wanted to break out some of that functionality and distribute it across other modules. So as you can see, we've got this the Lyft app module that handles the initialization of the app, which I think makes sense. And then it has deep links, which really I really wanted to focus on for this. And just as a refresher for anybody who may have forgotten what a deep link is, a deep link allows you to route to a specific screen within the app or a specific experience within the app. So we'd be able to send maybe a text message to a driver that would take them to a specific help screen or a settings screen. And so deep links are very tightly coupled to specific features, which I'll get into here. So if deep links were handled inside of the passenger app module, that means if the driver app module wanted to use deep links, then we'd have to take a dependency from the passenger app module on the driver app module, which really just doesn't make a whole lot of sense to me, because then we're not even splitting the app at that point. So yeah, it really doesn't make sense. So instead, what we decided to do was melt down that deep links and some of the other large components within the app module into specific features. So if you have a settings deep link that takes you into a specific part of the settings page, maybe it should live inside of the settings module. And if you had something, a help deep link, then maybe it should live in the help module, and so on and so forth. So we distributed all of the logic out for our deep links into separate modules. So that way, the Lyft app module no longer contained all of that functionality. And that way, we could sit both the passenger app module and the driver app module on top of these feature modules with the distributed logic, and then ship what we needed to in each app. All right, and we did this again for those long-running jobs and especially Dagger modules. This really helped the start times for the apps. All right, so we ended up with something that's actually very close to this. It's still very much a work in progress, but we're seeing like definitely some better performance on start times and app sizes. And I think it was a month ago that we actually shipped the passenger app with 0 driver code and 0 passenger code in the driver app. So it's been working out pretty well so far. All right, like I said, it was a pretty short talk. I think I mentioned that. If you guys have any questions, I think that microphone is where you can come and do that.
So one of the questions is, how do you properly manage so many modules within a lot of other modules and whatnot? in your, say, Git repo, for example? What's the best approach?
So we have just one Git repo, and each module sits in a specific folder. So we have a driver features directory that then has a bunch of modules that have to do with driver features, a passenger features directory, and then some other generalized directories like maybe mapping. We have a bunch of different modules within mapping and our API layers and frameworks. And so we kind of split it up in a logical folder structure that makes sense for people looking to find a specific module.
My second question, hopefully short, is how do you make sure that the code stays the same logic is the same across the board when you say, kind of going back to your deep linking pieces, kind of in more than one module at a time? Is it just making sure that the logic is the same and you guys kind of need to like copy and paste kind of it like within each module? Or
hopefully we don't have to do too much copying and pasting. So the goal here is basically that as we ramp up new members on the Android team, we have a series of guidelines that we have for like best practices within Lyft. And so it's mostly making sure that everybody understands some of these best practices and architecture decisions that we have. And if they follow those, then the code is generally the same. However, engineers are encouraged to make individual decisions based on their features that make sense for those features.
Okay, thank you.
Maybe you want to get in line for the microphone, if that's okay.
So my first question is, did you use Android Studio's tools in any way to make this refactoring easier when you were splitting everything into modules?
So we actually don't use Android Studio. We're all about IntelliJ.
Eclipse? Oh, okay.
Yeah. Oh, not Eclipse. Not Eclipse. No.
NetBeans, no. My second question is, were these modules that you made self-contained unto themselves? So did they have like UI, business logic, and stuff like that, or were there separate? Or have you separated all of your UI, for example, passenger, into one module that depends on the API module that depends on like, I don't know, other things?
Yeah, we've tried to split these modules up in a way that they contain all of their logic. So they contain UI components, they contain business logic, and so essentially self-contained features that you can show a screen, and that is that entire module.
Thank you.
Class participation as promised. I'm curious about the concept of module ownership that you talked about.
Sure.
How common is it that teams have to make pull requests to other teams' modules? And how does that pull request process work? Because if some random person is coming into a different module, I can imagine it might take their code review a long time to get reviewed. And like, how do you ensure that velocity stays up?
Yeah, that's a great question. So really, it's not super common to have to touch other feature modules unless if you're dealing with a feature that interacts with other features. However, it does happen every once in a while, and the more core modules obviously get touched more often as we need to tweak some of the core functionality of, say, our APIs or mapping layer. It's really mostly good faith on fellow engineers to look at PRs and make sure that they're participating in the PR lifecycle. Sometimes longer PRs do happen, especially if the change is more dangerous or more risky or more out there. More eyes need to see it and more discussion needs to happen. But usually it doesn't take too long to get a review out.
Thanks for the call and for the funny gifs. I assumed you were using Android Studio, and my question was actually how you manage the build, having one code base. How do you export? Are you using flavors or the equivalent in NetBeans? If I could add a second question is, I'm interested in the project management part. You said more than 100 modules, is it?
Yes.
What's the size of the team and how do you manage all that?
Sure. So the first question was flavors. So we do have flavors for our production, beta, alpha, and dev builds, but we don't have flavors for these other modules. So these other modules feed in to, I guess it's tangential to the flavors themselves. As far as the team, I think we're sitting at about 25 Android engineers right now. Each Android engineer owns the modules that they've worked on for features, and usually the code reviewer for new modules also be an owner on that since they understand a lot of the functionality since they reviewed it. And so the project management there, if an Android engineer needs to be using a module more often, they might start contributing more, and then eventually they'll talk with the current owners and be added on as an owner for that module because it makes sense if they've added a lot of new functionality. Absolutely.
Hey, so you mentioned Apk Size is one of the reasons why to split the app.
Can you actually share with us how much you were able to save on each?
It was pretty significant. If I remember correctly, I think it was something around 30 to 40% of the passenger APK
is
size.
the driver and the passenger app roughly the same size now?
They're slightly different just because they pull in different SDKs.
Right.
I think the driver app is slightly larger since we have a few different, pretty aggressively sized SDKs that we've included.
So the common, I guess the common code is still probably like roughly half of the app.
That's a great question. I'm not entirely sure exactly what the size of the common, but there's definitely a good chunk of common
Because
code.
then you need to download it twice if you just one bulk, right? So just one angle. Okay.
Okay, so you mentioned that you have like 100 modules in your app, and how do you promote state?
State throughout the app?
Yeah.
That could probably be a talk in and of itself. So the server actually provides the app with state, and then the app decides which screens, which features to be showing based on that state. And there's some actual navigation that can go on via the user that the client determines some state. But for like rides, it's important to make sure that the ride is in the correct state, whether you're picked up, dropped off, so on and so forth. And that's determined by the server.
Okay, so follow-up question, how would you do the instant app?
Well, we haven't, to my knowledge, haven't discussed instant app. I think this modularization would definitely help. I think there'd still be some work, though, to get that working. I don't think we've investigated as far as I know.
So, if you know the instant app, you have to have the base module, and you have like 100 modules or something like that. So, how would that work?
Well, the base module would probably be some sort of variation on either the passenger module or the driver module. So the main app module is there. And we'd probably create some like light version that only brings in the features necessary for whatever functionality we wanted to include in the instant app.
So my question is regarding, you have so many modules and you're sharing between those. How are you guys managing in GitHub? I mean, in the sense of like, do you have any different repos? All of them is in one repo? How's that work?
Yep, all of it's in one giant repo.
One giant repo.
Hey there, my question's around maybe converting riders into drivers. Is this splitting the app into two separate apps now that you have to download another one if you want to become a driver? Have those numbers been impacted at all, and how so?
So definitely something that we heavily considered while we were doing this. And as we were rolling this, the driver app out and not allowing the current passenger app to use driver mode, we were definitely keeping track of kind of the funnel and where that was happening. We do keep some driver onboarding within the passenger app still. So if a passenger does want to become a driver, they can get essentially all the way up to giving a ride, and then they can download the app. So really, at that point, if you've gone through the whole process, the last final little step is just downloading the driver app.
Thanks so much for sharing.
Absolutely.
Since you have a lot of different modules, how do you handle third-party libraries, especially versioning and migrations, and like different people have to migrate it?
Yeah. So for SDKs, if we're incorporating an SDK, usually what we'll do is write a wrapper around the SDK in a module. So that module will then contain that. However, our dependencies are universal throughout the app. So if you have an SDK that requires a certain version, then really the decision becomes, do we include the SDK or do we not, based on do we want to go to that version? And usually if the version is stable, known to be a good version, then we'll do it. But if it doesn't look like it's stable, we're not going to compromise stability for whatever that functionality was.
Hey, with 100 modules, how long does it take to build the app?
It's pretty quick. I think like 2 minutes tops. We use OKBuck. And with OKBuck, really, the more modules you have and the more fine-grained responsibility for each module, the faster it is. So it's pretty cool.
Do you use Gradle more or Buck more?
Well, so OKBuck actually uses Gradle modules on top of Buck. So we use Gradle modules, but then we use OKBuck to compile it.
Cool, thank you.
Hi, I just had a question about your Dagger setup. Like, how much do you leverage daggers, like multi-binding or things like that when you designed this app, or did you find out that it wasn't sufficient enough in any way? Just wanted to hear what your experience with that was.
As far as multi-binding, my email's up there. I might have to get back to you if you want to shoot me an email. I can get back to you on that. haven't looked at that in a while. So yeah, absolutely. If you want to shoot me an email, I can let you know.
Okay, but did you find it? Did you run into any issues? I guess heavily modularizing everything. Was there anything that like Dagger couldn't do that you found out, or
the biggest
you just use your own system for that?
No, we definitely use Dagger. And the biggest problem that we were running into while doing this was having strange circular dependencies. As we were breaking things apart and then trying to figure out how to break those circular dependencies out into a module structure that worked better. For me, that was definitely the largest issue that I ran into with Dagger.
Thanks.
Absolutely.
I have another questions regarding testing. Are you running all tests for all modules when you raise a PR?
Yes, so our continuous integration does run every test for every module.
Isn't it over, like, you don't need to run all tests, right? You need to run only your module tests.
I guess there can be unforeseen consequences with modules that depend on other modules. For our build itself, we do use buck cache so that we don't rebuild all of it, but as part of continuous integration, we run all of our tests.
Okay, thank you.
All right, well, thank you very much for coming, everybody.